Hello friends, today we will discuss series circuits. In our series circuit we have three resistors. We have a voltage source. Calling series resistors means they are connected to each other in a certain way. Now without wasting any time, let's move on to our question. Here we will find the value of R. RT is equal to work. It's R1 plus R2 plus R3. R is us equal to work. 6 ohms, 4 ohms, 2 ohms. What are we paying attention to here? We could add them directly because they were all in ohms. We would have converted kilo ohms and milliohms and then added them up like that. Let's pay attention to this. So R is 12 ohms. We say, friends, after finding the equivalent resistance, we find the current flowing through this circuit. How do we find that? V equals I times R. So I equals VR. What does that equal? 1 ampere from 12 divided by 12. So what is the value of the current flowing through this circuit? It's 1 ampere. Since it's a series circuit, the current is the same everywhere and is 1 ampere. Okay. Because the current going into the node will be equal to the current coming out, and since there's no other node, we will see it as 1 ampere in a series circuit. What should we examine right after this? Let's examine resistances. Let's say VR1. What is this thing we call VR1? It's I times R1. Since the current flowing is 1 ampere and the resistance is 6 ohms, the voltage will be 6 volts. If we want to find VR2, it will again be I times R2, which is 1 times 4, so it will be 4 volts. The voltage across R3 will also be I times R3, which is 1 times 2, so it will be 2 volts. Of course, how? Plus, minus, 6 volts plus, minus, 4 volts plus, minus, 2 volts, because the current, since it said that electrons flow from negative to positive. Now that we've found the voltages, let's find their power. For example, we can find PR1 using U times I. We can find it using U squared divided by R. We can also find it using I squared times R. How does this happen? Now let me show you like this, friends. What's our power formula? U times. Was that correct? So what did we say U is, friends? So V equals I times R. Wasn't it I times R from that formula? Yes. So what did we say? Did we say U over R? Here, if we have a known value, we take it and substitute it in. If we write I times R instead of U, we have an I here as well. I times K equals R. If we replace UR for I, U squared R, it gives the same formula for all of this. PR1 equals, we say it's U times R1 times I. What was UR1? 6. Since the current is 1, we say it's 6 watts. What about our PR2? U times R, 2, times I equals 4 times 1 equals 4 watts. PR3 equals U, R, 3 times I from 2 times 1. We say it's 2 watts. Well, let's find any other formulas as well. For example, PR1 equals, we said I squared times R. Correct. Since the square of 1 times R is approximately 6, it will be 6 watts. PR2 equals, from I squared times R2, that also equals, R1 also equals the square of 1 times 4 ohms. What does that equal? Equals 4 watts. PR3 equals, from I squared times R3, the square of 1 times 2 equals 2 watts. In the same way, PR1 equals U times the square of R1 divided by 6 volts across R1. 6 times 6 is 36. The square of 6 divided by, from 36 divided by 6, it equals 6 watts. As you can see, we can derive this from all the power formulas. But what is the thing we need to pay attention to here? In the formula we wrote, for example, we did the square of UR1 divided by R1. For example, when we say UR1 here, this is not the voltage of the main power source. As long as we pay attention to this, We find what in their powers, friends. That's all for the cities. We solved a simple question for better understanding. Of course, we can solve a more difficult one if needed, but the logic is simple and easy. Don't forget to subscribe to our channel and like our videos. Take care yourselves.